This video is about defining functions in Mathematica, and this is a more powerful method, but unfortunately if you don't use it carefully you will run into a lot of errors and really annoyed by those error messages. So it's a better method, but you have to be aware of all the sensitive parts. First thing I want you to remember is that when you define function, there's always this colon. Then remember you have to use this colon and underscore, these two things. And you will see this example, but I want to remember always when you define functions, not just in expressions or numbers, you have to have this colon and underscores. And when you use it, when you define it, and for both cases, you try to distinguish from the functions from expressions. So functions involve the variables, and expressions is just the unknown letters and indeterminate. It really requires experience to distinguish these two things, but at this stage I want to remember the three things. If you're having trouble with these functions, these three things are probably causing you problems. So here's an example. This long name, you can make it any simpler and shorter name, but I just named it this way, function 1 and bracket, and this is the variable, and underscore. This means it's a pattern. No matter what you put it in there and what this is going to do with whatever is in between this bracket, they'll subtract 2 and divide it and do the rest of the part. For example, if you type in function 1 z, if it knows what z is, if it doesn't know, if z is in blue, that means z is just a letter, then it's going to show z minus 2, z squared minus z plus 4. And if you plug in numbers, numerical value of pi, then it'll calculate this one. It's going to actually evaluate this exact thing with x equals pi in it. So as shown below, and the first part is exactly z minus 2, z squared minus z plus 4, and the second part evaluated this one at pi and gave the numerical value. Sorry about that. This is an example where we use unknown constant, the so-called parameter. We usually deal with the one variable functions, but some of the coefficients sometimes it changes, and we look at what happened to the function as you change the kind of constants involved, the so-called parameters. It's really convenient to define it this way, and I really like this part of the Mathematica, and it separates this parameter part, constant parts, from the variable. You can do that. So this function 2 bracket, all these things serves as one name. In the earlier part we had the function name function 1, but this entire thing right before the x can serve as a function name. But right now we are also defining as a pattern and a variable. Whatever you put it in there, and it's gonna, with this a, b, c, and x, what it's going to do is this thing. So it seems like a function with the 4 variables, but again, the advantage of separating this a, b, c from x is that you can use this part right here without the x part. You can use that as a name, and any operation that only involves a name of a function, then you can use this as a name of a function. For example, if you do this, function 2 a, b, c, z, if a, b, c are in blue, then it'll just spit out a, b, c in there, and instead of x it's going to have z in there. And if you instead put 1, 2, 3, and it's going to replace a, b, c with 1, 2, 3, and x value with the square root of 2 as a numerical value. So that's what's shown here. I would like to make this part of the video simple, so I'm not going to actually show you the advantage of separating this parameter from the variable like this, but we'll just keep it that way, and then it's something useful. So let me show you a few more examples. For example, if you want to use different letter instead of x, you can easily replace it just a t, putting a t there, and this whole thing with the function with the coefficient a, b, c is probably still unknown at this stage, and differentiating it 2 times. So whole expression goes in there, and the correct variable and number of differentiation you want to do. So this is going to be second derivative of this function with respect to t. And the second part is with actual coefficient 1, 2, 3, it's going to differentiate and simplify. And then the third one is that differentiate 4 times, and after all that, we're going to plug in t equals this pi with this 20 decimal precision. Let me warn you here, if you plug in pi at this stage, and what it is doing inside this bracket, and here they try to differentiate this inside, but if you replace this one with a pi in there, and it's going to recognize this one as a constant, and derivative is simply 0. So especially when you deal with a derivative and functions with the variables, always think about the order of operation. Many of the error messages is coming from the incorrect order of operations. So if you execute all that, this is what's showing. These are the second derivative with actual numbers in the second part. And if you actually evaluate this one at pi and with this much of precision, and that's the numerical value. Again, sorry about the incorrect keystrokes. And here's an example that order of operation is important. For example, I'm defining this function. The name of the function is simply f, as we usually do that in classroom setting. The variable here is x. It's actually whatever that is inside the bracket, called pattern in Mathematica, and with this underscore and colon there equals this expression. So that's going to be this function you see a lot in the calculus course. And second command line is a derivative f of x, where I chose this x. You can change to something else, z and z here. And if you put x and z there, and if you differentiate it with respect to x, it's going to be 0. It doesn't recognize this as a variable. Z is going to be a constant. So you have to keep these two things the same. So this is going to be second derivative. And Mathematica computes it to be the following expression there. Now let me explain what happens if you execute this command. So you think this is the derivative, and this is just the bound. This xl is -2 and xr is a +2. So that's negative and +2. Sometimes I want to change the setting later, so sometimes it's convenient to do it this way. So the problem is this part here. We're plotting this derivative between x equals xl and xr. If you actually execute in the Mathematica, you will get an error message because if you think about the order of operation, it does not really do the differentiation you want it to do. So for example, what this one does is that they will choose all the different x values in there, that is in between this xl and xr, and they're going to plug it in there first. No matter whatever the x appears in here, they're going to replace that x with a number in there, and then it will go through the differentiation. So for example, if x is actually a number, and then they plug it in there, so f of some actual number, that's not really a problem, but this will be a problem. And this d command wanted to recognize this x part as a variable so that it can consider the differentiation. Now x is changing because of this thing to a number. So what we have to do is that we have to use a different letter and to go through the differentiation first, then plug in x equals 1 some value so that it turns out this is a numerical value for each of this x. So it seems like very, very inconvenient things right now, but if that's what you have to go through, you have to use a substitution rule and then fix it. But after that, I'll show you how to do this in a better way. But there isn't always just a quick shortcut and using some other Mathematica command. Sometimes your task is complicated and you have to look at the order of operation carefully and fix the problem if there's an error message. So I actually wrote it up here. So for example, if x is 0.5 and they try to figure out this value and try to plot it, but what they do first is that go and replace everything in here with a 0.5, and this code to this part doesn't make sense. It cannot evaluate this one. It wants this one as a variable, but right now it's a 0.5. So here's one solution. We're actually using this x, and x is going to go through these values from -2 to +2, maybe skipping very, very tiny amount, and every time it's going to go and replace everything in here with that value and try to calculate the y value to sketch this graph. So what we have to do is that we have to differentiate first, then replace it with this x value there choosing it here. So when you differentiate, we want to do this one with a different variable, such as like xx in here. And what this one will do is it's going to differentiate with respect to xx first, then replace that xx with this chosen numerical value to plot this one. So this will work. This is another version that'll work, and prior to the plot command, we're going to define this one as a function. So if you have x value, the thing that we wrote in is going to define it as a code. Again, if you're just using x in here and x there and not having this code, you're going to have an error, because every time 5 a number, it's going to plug in that number first, then do the different this d command. Whenever that happens, is this xx is going to be if this is a number, it's going to be a problem. So it looks like a very inconvenient way to define the derivative, but at this stage I'm just introducing a way to fix a certain problem, and I'll show you the better way to deal with the derivative. But again, this is an example of dealing with a problem caused by order of operation. So once you define this one, FDR, as a derivative correctly like this, then of course you can call that, and if you sketch it, it's going to sketch it correctly like this. So I actually wrote it here, and then what happened if you actually define the derivative in this way. Okay, this seems like the derivative. The same problem that you put this one inside the plot command, it causes a problem the same way. So for example, if you define it this way, what the computer will, Mathematica will do, every time you see FDR, for example 5, what's it's going to do, it's going to replace this x with a 5, and that x with a 5 as well. So you will end up at having at 5 comma 2. Well, actually I'm using 1, so the same thing at 1 and 1 2 here. So this code doesn't make sense to Mathematica. This part's supposed to be a variable. So if you evaluate FDR1, and you will have this following error message, which is caused by this not being able to recognize this 1 as a variable. So you have to differentiate like this first, using a different letter, and then you have to evaluate. Now, there's of course a better way to actually deal with just the derivative part, so here's how you do it. If you define the function with the name f, and here make sure you understand this part is a bit abstract. It's only dealing with the name of a function. It's not dealing once it's defined in earlier stage. Does not deal with what the variable is. It's only dealing with the name of the function. This one means first derivative. So if you use this command, the derivative, first derivative of a function with a name f, and then that whole thing is going to be a different function. You don't have to put x or anything. It already knows how the variable looks like, so it only deals with the name part. So this f first derivative, I named it. This can be name of a new function. If you want to use this function, you have to put the variable in there. Like this. It's this function is properly defined with a name f first dir, and then if you wanted to see how it looks like, you got to put this variable or a number, anything, then it'll show the output properly. And this is what you're supposed to have. But it all depends on you define f earlier. Alright, here's another example. If you want the third derivative of the function defined, so that will be this way. Again, this is just a name. By typing this one and you are giving the variable, it could be anything, z or x and y, whatever it's in there, it's going to show the result. So if you execute that, and it's going to show you the third derivative result. And once you define the derivative properly like this with a name, it's easy to plot. If you just put this name and the z the z variable, it can be x, whatever the dummy variable you use here. Since the third derivative is properly defined here, you can just plot it in this way. And then it's going to show this type of result.